Hello all. On behalf of Transoft Solutions, I welcome you all to the 6th webinar in 2019 AutoTURN Tips webinar series. For those of you who don't already know me, I'm Charles Sebastian Chalusheri, and I'm a civil technologist with Transoft Solutions, working in the product management team within the simulation BU, which takes care of all the AutoTURN family of products. Today, the presentation is all about using IntelliPath for analyzing traffic calming. This presentation shall be approximately 30 minutes long, followed by a short 15 minutes question and answer session. At the end of this presentation, we would like you to complete a 2-minute survey, as we really appreciate learning more about our customers and how you use the software. So with that, let's start. So here goes the agenda for today's webinar. So I'll start the presentation by explaining a bit about what traffic calming is, the need for traffic calming, and how it is done. After this, I'll briefly go over the major traffic calming measures that affect the swept path of a vehicle directly and explain the advantages of using IntelliPath, the tool in AutoTURN Pro, to analyze traffic calming. After this, we'll jump right onto our technical demo, and then we'll talk a little bit about the project support services and move on to the question and answer session to conclude the presentation. By the way, feel free to ask questions throughout the presentation. So what is traffic calming? Traffic calming is the use of physical solutions like design changes, or it may be implementing physical barriers and other measures with an aim to reduce traffic speed or cut through traffic, with the goal of making streets safer and more accessible for motorists, cyclists, and pedestrians. So the traffic calming has been proven as an effective way to reduce speeding on residential streets, and it has also been found to avoid traffic crashes or collisions, and also prevent needless fatalities due to these collisions. Traffic calming, in general, aims to encourage safer and more responsible driving. It also helps improve the comfort level of the passenger and potentially reduces the traffic flow. So in short, traffic calming helps eliminate the negative effects of motor vehicles on the road, and it improves the conditions for non-motorized street users. Traffic calming has been successfully used for decades in cities across Europe, and more recently, in response to growing number of traffic accidents and speeding issues, cities across North America have begun adopting traffic calming programs to improve safety and livability on the streets. Various studies have shown that traffic calming can reduce vehicle speed and volume considerably. Some regions found a drop of more than 10 to 16% in the total traffic volume, and found that more vehicles were traveling at a lower speed, which is less than 23 miles per hour or 37 kilometers per hour, after the implementation of traffic calming measures in various regions. The accident levels were found to drop by 40%, and also the fatalities due to these collisions were reduced by 33%. Over the past 10 years, pedestrian fatalities in Germany have fallen from 6.2 per 100,000 of population to 2.3. This has been largely due to lower vehicle speeds in urban areas, which is due to the heavy investment in traffic calming programs. An overall reduction in the personal injury accidents of 41% was achieved in Berlin, with a reduction of fatalities by 57%. A review of over 600 traffic calming schemes in Denmark indicated that there has been a reduction of 43% casualties compared with the untreated areas. Many studies have also found that traffic calming greatly reduced the air and noise pollution in the treated areas, as well as improved the street aesthetics and positively impacted property values. So how is this implemented? The traffic engineers or public work officials or the urban planners have many strategies for implementing traffic calming programs, which is entirely based on the region and the requirement. So all these solutions are used to create more complete streets that offer safe access to all users. So the principal techniques used in traffic calmings fall into four main areas, which is the vertical deflections, visual displays, horizontal deflections, and lane narrowing techniques. So the vertical deflections are mainly structures like speed humps, speed cushions, speed tables, and rumble strips, and etc. There are many more. Visual display include speed displays and other message display signs. The vertical deflections and the visual displays do not have a direct impact on the swept path of the vehicle. The traffic calming measures that have direct impact on the swept path of the vehicle are the horizontal deflections and the lane narrowings. So the most commonly used method in horizontal deflection are chicanes, curb extensions, bulb chokers, pedestrian refuge islands, and traffic circles. These methods deliberately make the vehicle slow down or alter its normal path, which creates higher driver attentiveness and safe environment. The lane narrowing techniques helps slowing down the vehicle by reducing the space available for the vehicle for travel. The most common methods used are widened footways, dedicated bike lanes, adjacent parking bays, bus lanes, using of markings and boulevards. Now let's see what is IntelliPath. So most of you have already heard about this tool in AutoTURN Pro. So IntelliPath tool in AutoTURN Pro is an automated swept path analysis tool which analyzes the routes and various constraints within the routes and automatically creates a simulation while keeping a check on the vehicle limits and making sure that none of the parameters are exceeded. This tool can generate and evaluate all possible vehicle paths through a route in seconds. It also helps you evaluate multiple vehicles within the same route and calculate the maximum achievable speed for the vehicle for a particular movement. So all of these mentioned functionality of IntelliPath tool can be particularly useful for evaluating the effectiveness of traffic calming programs and examining the potential impact of traffic calming measures implemented. It also helps measure the incremental or the bundling effect of multiple traffic calming devices used together. With this tool, many different possibilities or combinations can be tested easily. Multiple vehicle behaviors can be reviewed quickly in no time. And all these factors collectively contributes to save time and effort and in turn increase the productivity. So with that, let's jump onto our technical demo to see and understand the mentioned points better. So for a general overview, working with IntelliPath tool is very easy and straightforward. So there are three main steps in the analysis. The first step is to select the analysis area, which contain all the exclusion zones, the routes, and the vehicles. Now we have to select the exclusion zones, which are also known as non-drivable areas or boundaries. The third step is to select the desired route for the vehicle. And finally, picking the desired start and end position of the vehicle within the route will let the software create the simulation automatically. So let's see how this happens. So for this scenario, let's evaluate a downtown situation where traffic calming measures like chicanes and curb extensions are popular. These measures aim at reducing the traffic volume and speed without impacting the emergency vehicle response times. So in this particular scenario, as we know, to the downtown, the most number of vehicles entering the downtown area would be passenger vehicles. There will be city bus for transit or transit buses, and also occasional fire trucks or garbage trucks or emergency vehicle that has to enter the areas. So let's analyze the situation, the section A of the downtown, and let's consider we have to analyze this chicane for a city bus. So now let's select the city bus from the vehicle tool, and from the ASTO 2018. Because this scenario is in Vancouver, downtown Vancouver scenario, I'm using the left-handed vehicle from the ASTO 2018, which is the city bus. And let's see how this vehicle behaves, or how we can drive this vehicle through the section A. So let's start the vehicle over here. Let's pick the vehicle point, orient the vehicle, use the ArcPath tool to drive the vehicle, and the bus might oversteer a little bit in order to avoid the obstacle, and it goes straight. So this process might take a bit longer, where you have to check all the constraints, have to see the turning characteristics, you have to check the speed, and you have to see that the vehicle body doesn't encroaches into any other space. So this would be the typical maneuver which we have to check. So you can see that there are multiple picking points or stoppage points. And in our previous webinar, we have already seen that the number of sections, when it's increased, the simulation may not be the perfect one. So what can we do to avoid these situations? So let's see what IntelliPath Tool can do. So for that, I'm hiding the chicanes for a bit, and let's see a perfect route from this point to here and how IntelliPath does it. So the IntelliPath tool can be found in the ribbon of the tools within the AutoTURN, and clicking the tool opens a window, and like I explained earlier, these are the steps for the software to recognize about the tool. So first is picking the route analysis area, and then next comes the exclusion zones, next comes the exclusion lines and lane lines, and etc. So let's select the analysis area. So selecting the analysis area, we can either pick different points outside the area, or if we have a closed polyline, it's easier with just one click. It selects the whole area. So this can be a line or a polyline, a closed polyline. But a closed polyline would be the best option for the software to easily select this. Now let's select the exclusion zones, which the vehicle has to pass through. So this is one. It's taking some time because lots of software is running at my background, and then I'm recording the presentation. So it's eating up my graphics card. So by just picking these points, these areas are considered to be exclusion zones or non-drivable zones, and the vehicle tires will not pass over these. So in order to test the section A, I have to select all these exclusion zones in order for the vehicle to recognize the route perfectly. These can be done within seconds. And now let's right click to end the tool. And if there are any exclusion lines, so in this case there's a two-way road and you don't want the vehicle to encroach over this line, so you can select the exclusion line And similar way, pick the exclusion line and right click to end the tool. And there are also an option to select lane lines. So lane lines are softer or boundary lines which the vehicle passes over but keeps the vehicle in a line. So in this particular case, this is a one-way road with 2 lanes, and if you select this as a lane line, so the vehicle automatically understands that if it has to pass this lane, it will be either orienting on this lane or on this lane. So I'll just show you later. In our first example, we'll see how the lane lines work. And for now, let's right click to end the tool. So this is easy. We selected the analysis area. So all the routes, exclusion zones, the vehicle should be contained within this. And now we selected the exclusion zones. And next step is to add the route. So let's see how a vehicle would travel from this route to here, going down through A and inside. And right click to end the route. Let's add another route from this point, but I want to analyze the section A again till here. So let's right click to end the tool. And now let's add some movements for the vehicles. So let's see how a city bus would travel at, let's say, at lower speeds, let's say 6 km/h, and let's click OK. And now we have to orient, we have to pick the starting point, orient the vehicle properly, and then click the end point of the vehicle. And the software automatically calculates the movement and creates it within seconds. So you can see that the bus did not oversteer as we did. So it was a bit more perfect. It did not go over the exclusion lines. It went straight and then went in. So this is the first situation. Let me uncheck this maneuver and uncheck the other route. Now let's add a movement for the passenger cars. Let's see the working of the lane lines. So select the passenger car from the ASTRO 2018 website, same speed. I'm orienting the passenger car here, and now I'm letting the software know that these are lanes, and then because my vehicle has to turn right, the vehicle has to first move to the right lane and then turn right. And now we can click here to end the route. And you can see here that within seconds, within no time, that IntelliPath recognized that the vehicle has to move to this line. So it recognized this as a lane line, and it orients the vehicle perfectly after crossing over the lane line and making the maneuver. So I'm turning off this one, and let's add one more vehicle, which can be from the NCHRP report library, which facilitates for a fire truck. Let's select the aerial fire truck, and with the same speed and CATX56, let's select the vehicle or orient the vehicle, and let's see how this vehicle travels. So similar to the city bus, it travels and reaches the endpoint. Now I'm switching off this one, and let's add the same vehicles in our second route. So I'm turning this off. So let's add a movement, and same vehicle, let's click OK. Let's click and orient the vehicle, and let's click the endpoint, and the vehicle travels. Let's add another movement. for the city bus. Similar movement. Let's orient it quickly and end the movement. And that's done. So now, we know that these paths are, or these vehicles can travel through this path successfully and with the speed limits which we provided. Now let's see how these vehicles travel when there is a chicane, or when we consider a traffic calming chicane. And so once we selected the chicane, let's go back to the IntelliPath tool, and now we can see how easy it is to add the chicanes. First, we can remove the area selected as the exclusion zone, and then add the chicanes as a new exclusion zones. Right click to end the tool, and now when we turn on the road, you can see that the route has adjusted according to the exclusion zones or the chicanes. Now let's see how the city bus travels. So you can see here that the path of the city bus is automatically adjusted by the software to match the chicane, or to match the new exclusion zones. Let's try it with passenger cars. You can see that it passed through, and even the fire truck, you can see that it passed through. So now let's analyze the second route with the same chicane. And so this is for the fire truck. Sorry, we have a small issue adding the routes. I'm just going to delete this route once again and add this once more. Then when we are adding a movement of the fire truck, let's click OK. Same thing. So the software is calculating various possibilities how the vehicle will travel, and you can see that this vehicle does not make this maneuver. So software clearly says that it failed because of the turning radius, and this particular method cannot be adopted if we have to consider for the emergency vehicle access through this route. So another easy method is, so we know that this fire truck has failed. So let's check the same route with a different vehicle. So just double click the already created simulation, and then you can easily change the vehicle by selecting the vehicle from here. So let's check for a pumper truck. Just click OK, and then click OK, and then software will automatically update the same simulation with the pumper truck. So you can see that even the pumper truck, which is smaller than the aerial fire truck, does not pass through this chicane. Hence, you can clearly say that this traffic calming measure scenario is a fail. So let's delete the roads, close, and then let's try another traffic calming measure, which is the kerb extensions. So for that, I'm turning on the kerb extensions, and I'm going back again to the IntelliPath tool, and I'm deselecting the chicanes, and I have to select the kerb extension as the new traffic calming technique. So select this, right click to end the tool, and once again let's turn on the road, and when we turn on the path, you can see that it automatically updates and the vehicle does pass through properly. You can select other alternate routes. You can change the route color of this route so that we can easily identify it. And we can turn on these simulations to see if the fire trucks pass through. So you can see that with this traffic calming measure, the vehicle can easily pass through. And now with IntelliPath, you can do one more feature, which is checking the maximum achievable speed by the vehicle. So this can be beneficial if there is a speed restriction in the road, and then you can decide on what type of calming measure or what combination of calming measure to be applied. So this is simple. So let's see that the fire truck, let's turn it on. So the fire truck, you can see that it passes through the curb extensions, and now when we double click it, you can see that the speed we specified was 6 km/h. We can also have IntelliPath determine the maximum achievable speed. So let's do that and click OK. It might take a little bit longer, so that as the software has to calculate multiple options and to satisfy this total maneuver. So the software at the background will be calculating all these factors and will give you a speed as well as a simulation. So you can see that speed has been updated to 17 km/h. So that means this particular vehicle, which is a fire truck, can travel at a maximum speed of 17 km/h at the most constrained areas of the route. So with these features, collectively adding together, you can easily analyze an area for multiple vehicles and for multiple routes and multiple traffic calming measures combined. So it all can be done within seconds. So we only need a bit of time to create this area or to set up this area for the tool to recognize as the analysis area and the exclusion zones, etc. So thank you so much. With that, let's jump back onto our PowerPoint slides. So as we already know, one of the most important factors in accurate swept path analysis is using the proper vehicle for analysis. So Transoft's project support service team of engineers offer a custom vehicle creation service to help you model unique vehicles which are not currently available with AutoTURN's vehicle libraries. So for example, if you want to model a specific vehicle from a manufacturer or from a design guideline, our service will create the vehicle for you for a small fee so that you can perform an accurate analysis. If you're interested in availing the service, simply contact our engineers at pss@transoftsolutions.com and provide them the required vehicle information like the vehicle dimensions, steering characteristics, profile drawings, etc. And based on the given information, we can provide you a quote and an expected delivery time of the vehicle. So you always know that the AD Tips webinar, which is the AutoTURN Tips webinar, are held the third Wednesday of each month. We'll be back next month with a new topic. And in June 20th, we are having a webinar about ParkAD, which is designing of parking lots. And June 27th, we are having a webinar on Guide Sign Plus, which is the designing of guide signs. So let's come back to watch it on June 20th and June 27th. And next is the global technical support. If you have any difficulties or any questions, you can always feel free to contact us at the support@transoftsolutions.com. And our sales in North America and Canada are sales@transoftsolutions.com, and the Asia Pacific sales is sales APAC@transoftsolutions.com. For more information about Transoft Solutions, our products, our pre-recorded webinars, and all kinds of stuff, please visit www.transoft.solutions.com. So with that, we have come to the end of today's session. Thank you very much for attending this presentation. Now I'd like to open the floor to you all. Feel free to ask any questions you have about any features in AutoTURN or Pro. I'd be happy to answer any questions you may have now. Thank you.